Okay, so let's look and see what happens. We've talked about beta oxidation, but let's look and see how many cycles or figure out what happens for each different type of fatty acid. So the number of cycles of beta oxidation depends on the length of the fatty acid. So for example, if we have 14 carbons in our fatty acid chain, that means that you divide that by 2, and that's going to be how many acetyl-CoA groups are formed. So carbons divided by 2, so 14 divided by 2 is 7. So we would get 7 acetyl-CoA molecules out of a 14 carbon fatty acid. That means that in order to, how many cycles of beta oxidation you need is 1 less than that. So you take this number of acetyl-CoAs, 1 less than that because that first one's already oxidized. So it's just 1 less. So let's do maybe 18. If you had 18 carbons, you divide that by 2, and that's 9 acetyl-CoAs. Minus 1 is how many cycles of beta oxidation you would need for this reaction to occur. So how much ATP is formed from a fatty acid oxidation? Again, that is dependent on for one fatty acid, it's dependent on how long it is. But for one cycle, we can say how much is formed. So in each beta oxidation cycle, in those steps, those 4 steps, we have 1.5 ATP from FADH2, 2.5 from NADH, and then we form 1 acetyl-CoA, and that is 10 ATPs formed from the citric acid cycle through everything. So per total beta oxidation cycle, you get 14 ATP. So let's say we have, let's figure out our total amount of ATP that we'd need or get from a specific fatty acid. So let's say myristic acid. So it's 14 carbons long, so it's important to remember. So our activation is -2. Just to start off, we have to get that first acetyl-CoA or first CoA on there. Because we're going to we'll end up forming 7 acetyl-CoAs. Remember, that is the number of carbons divided by 2. So we'll make 7 acetyl-CoAs. Each acetyl-CoA will go through the citric acid cycle and make 10 ATPs. So then we'll have 70 ATPs from our 7 acetyl-CoAs. Then we also have the process of beta oxidation. So we can't just do our 14. So remember, we had 14 up here ATP. We can't just rely on that for our total number of ATPs. First off, because we have our activation step, but also we get 7 acetyl-CoAs, but only 6 oxidation cycles. And so we have to make sure we account for all of that. So in 6 beta oxidation cycles, remember, 1 less than the number of acetyl-CoAs formed, we would overall get, 24 ATPs. So 94 ATPs are produced, but we use 2 in the activation. So we would get 92 ATPs out of a 14 carbon fatty acid. That's a lot. That's why fats have lots of energy. So let's look at our learning check. The number of acetyl-CoA groups produced by the complete beta oxidation of palmitic acid is how many? So this is going to be our number of acetyl-CoA groups, right? How many 2-carbon CoA groups do we have? So we're going to take our number of carbons and divide it by 2. So that would be 8 is our answer. The number of oxidation cycles to completely oxidize palmitic acid is blank. So how many oxidation cycles? Remember, this is 1 less than the number of acetyl-CoA groups because we already have that first one oxidized. So we would have 8 acetyl-CoA groups, meaning that we only have to do 7 oxidations of that molecule, of that fatty acid.